Walk into any West African kitchen in Nigeria, in Ghana, in Senegal, or anywhere and somewhere in that kitchen, something is sitting in a corner deliberately rotting, and whoever put it there is completely unbothered by it. The soup base, the seasoning paste, the locust beans your grandmother wrapped in leaves 3 days ago are all intentionally fermented. And if you grew up in that kitchen, you never once thought to question why. The reason West Africa ferments more of its food than almost any other region on Earth has nothing to do with taste and nothing to do with tradition for tradition's sake. It goes back to a geography so brutal and so specific that fermentation wasn't a choice people made. It was a choice the land made for them, and it kept entire civilizations alive. Look at a map of West Africa. You are looking at a region that sits almost perfectly along the equator. The sun here doesn't rise and set at an angle the way it does in Europe or East Asia. It comes almost straight down, every day straight for all years. Average temperatures across the West African interior sit between 25 and 35 degrees Celsius. In the Sahel, the dry zone just below the Sahara, it regularly exceeds 40. Now think about what heat does to food. In Europe, a piece of meat left out overnight is questionable. In West Africa, that same piece of meat left out for 4 hours in the dry season is already dangerous. Bacteria that take days to multiply in cold climates multiply in hours here. Before refrigeration, which for most of human history didn't exist, this was not an inconvenience. This was just like a death sentence. A 2020 study published in the journal Nature Food estimated that foodborne illness kills roughly 420,000 people globally each year, with sub-Saharan Africa carrying one of the highest burden rates. And that's today, with modern medicine. 500 years ago, one bad harvest season, one failed storage attempt, and an entire community could be eating contaminated food with no way to know it. Geography gave West Africa a problem. A brutal, daily, unavoidable problem. Fermentation was the answer. Here's what most people don't understand about fermentation. It is not just preservation. It is controlled biological warfare. When you ferment food, you are deliberately introducing specific bacteria and fungi, the good kind, and letting them colonize the food before the dangerous kind can. The good bacteria produce lactic acid and acetic acid as they work. Those acids drop the pH of the food. They make the environment hostile. Dangerous pathogens, Salmonella, E. coli, Listeria, cannot survive in that acidic environment. You are essentially building a biological fortress around your food using living organisms. A 2014 review in Comprehensive Reviews in Food Science and Food Safety confirmed that traditional fermented foods in West Africa showed significant reduction in aflatoxin, a deadly mold toxin that is particularly dangerous in hot, humid climates and that destroys improperly stored grains. The researchers found that fermentation wasn't just preserving food, it was actively detoxifying it. Your grandmother didn't know the word aflatoxin. She didn't know what pH meant, but she knew what is passed down through generations, that food she prepared in a certain way, left to sit a certain number of days, smelled right and tasted right and kept her family alive. That knowledge is thousands of years old. Let's be specific, because the variety here is extraordinary. Iru, called dawa dawa in Hausa, ogiri in Igbo. It's a fermented locust beans. If you've eaten any real West African soup like egusi, ogbono, eforiro, you've tasted it. The smell is sharp, almost aggressive. The taste is extremely great in a way that's almost impossible to replicate artificially. A 2016 study in the Journal of Food Science and Technology found that iru contains high levels of riboflavin, niacin, and essential amino acids that are largely absent in the unfermented bean. Fermentation didn't just preserve the locust bean. It transformed its nutritional profile entirely. Ogiri, made from fermented melon seeds or castor oil seeds, used as a flavor base across Igbo and Yoruba cooking. Similar function to iru, different base ingredient, independently developed. Gari. Fermented roasted cassava, now so common, was actually introduced to West Africa from South America in the 16th century by Portuguese traders. Within generations, West Africans had fermented it, not because they were told to, because the geography demanded it. Raw cassava contains cyanogenic compounds, natural chemicals that release cyanide when metabolized. Fermentation breaks those compounds down and removes them. People who skipped the fermentation step got sick. People who didn't survived. The fermentation of cassava into gari is not a recipe. It is an adaptive survival response that happened within living memory of the crop's introduction. Ogi, fermented maize or sorghum porridge, fed to babies across Nigeria, called akamu in the east. The fermentation reduces the presence of harmful bacteria and increases digestibility for immature digestive systems. A 2009 study in maternal and child nutrition found that fermented gruels like ogi showed significantly lower bacterial contamination compared to non-fermented preparations made under similar conditions. Palm wine. Fresh palm wine begins fermenting within hours of tapping. The natural yeast present on the palm converts sugars to alcohol almost immediately. In a region where water sources were frequently contaminated, slightly alcoholic palm wine was functionally safer to drink than river water. This was not accidental. Every single one of these foods represents the same equation. Hot climate leads to fast spoilage. No refrigeration leads fermentation as survival. But the heat is only half the story. West Africa also has two distinct seasons, the wet season and the dry season. And they are brutal in opposite ways. During the wet season, roughly April to October depending on the zone, rainfall can be intense. Humidity sits above 80% in coastal areas. This is perfect weather for mold, fungal growth, and rapid bacterial spread. Food that survives in February will not survive in August without intervention. During the dry season, particularly in the Sahel and the Savannah belt, the Harmattan wind comes down from the Sahara. Dry, dusty, cold at night, blazing during the day. This is actually better for some drying preservation methods. But for communities that needed protein-rich food year-round, drying alone was not enough. The fermentation calendar in West Africa essentially tracks the agricultural and seasonal calendar. What you ferment, when you ferment it, and how long you ferment it has always been tied to what the land and the sky are doing. A 2018 ethnobotanical study published in the Journal of Ethnobiology and Ethnomedicine documented over 200 distinct fermented food products across West Africa, with significant variation by climate zone within the region. Forest zone communities fermented different things than savanna communities. Coastal communities used different base ingredients than inland ones, but the practice itself was universal across all zones. Geography shaped the method, climate shaped the ingredient. But the logic was always the same. Here is the part that matters most. Refrigerators exist now. Preservatives exist. Supermarkets in Lagos and Accra stock vacuum-sealed, industrially processed food from around the world. And West Africans still ferment. Not because they don't have options. Because fermentation does something that refrigeration and preservatives cannot replicate. Fermented foods contain billions of active microbial cultures, what we now call probiotics. Lactobacillus, Bacillus subtilis, Saccharomyces cerevisiae. These organisms, when consumed, colonize the gut and have measurable effects on digestion, immune function, and even mental health via what researchers now call the gut-brain axis. A 2019 review in Frontiers in Microbiology documented the probiotic content of traditional West African fermented foods and found them comparable, in some cases superior, to commercially produced probiotic supplements in terms of diversity of bacterial strains.
Modern nutritional science spent decades telling people in developing countries to modernize their diets, to process their food, to industrialize, and then spent the next decade discovering that the traditional fermented foods they had been replacing were in many ways nutritionally superior to what replaced them. The geography created the need created the knowledge. The knowledge was passed down as culture, and the culture, it turns out, was right. There is a woman somewhere in a compound in Abeokuta right now, or Kumasi, or Dakar. She is wrapping locust beans in leaves and setting them in a warm corner to ferment for 3 days. She will not explain to you the science behind what she's doing. She will not cite a study. She will just say, "This is how you do it. This is how it's done." But what she is actually doing is executing a technology that her ancestors developed in direct response to one of the most demanding food environments on Earth, a technology that is thousands of years old, a technology that kept entire generations alive before antibiotics, before refrigeration, before anyone had words for bacteria or pH or aflatoxin. And here's the most striking thing: the Western world is now selling that exact technology back to them in capsule form for $20 a bottle, calling it probiotics, calling it a wellness trend, acting like it was just discovered. It wasn't discovered now. It was always there in the pot, in the leaves, in the smell that hit you when you walked into the kitchen as a child and didn't think twice about it.